Hi, my name is Brad Frieden. I'm a logic analyzer applications engineer with Agilent Technologies. I'd like to show you why Agilent provides 1. The most intuitive view of your FPGA system, 2. The fastest and simplest process to get those signals on screen, and 3. The most reliable capture of those signals. And I'd like to do this with a side-by-side comparison. Let's look at the Tektronix solution implemented with the First Silicon Solution FPGA View application and compare that with what Agilent Technologies offers with the FPGA Dynamic Probe. Before we start these measurements, let's take a look at our setup. We have 2 identical target systems. Each has an Altera Stratix FPGA. I'm probing it with flying leads. I'm hooking to the JTAG chain with a USB blaster. We want to get access to some important signals inside the FPGA. There's an up counter, a down counter, a PRBS generator, and a state machine. These are some critical things we need to see to know, is this system working properly, and if not, how to fix it. Let's take a look at how Agilent's FPGA Dynamic Probe gives you a much faster and more reliable way to capture these FPGA signals. Here's our view of the Agilent Logic Analyzer interface. I have a tool called the FPGA Dynamic Probe that's part of the Logic Analyzer interface that I can launch. And that brings up a basic interface where I can do things like connect to my target with the JTAG cable, configure the device with my design that includes that measurement core, import the bus and signal names that I'll be probing, and do the physical mapping of the FPGA pins over to the Logic Analyzer input channels. So let's walk through those steps. If I press cable connection, I see that USB blaster cable, and I press OK. It makes a connection, and now I can press configure device and go to my design file with the measurement core. And when I press open, it's telling me to please import the bus signal names. So I press that button and select a file that was created when I inserted the measurement core with the Quartus tools, and that imports all these signals that I'm going to be probing. Finally, I press pin mapping and select add probe and flying leads, since that's what I'm using. Up pops a menu where I can then map these output pins of the FPGA over onto the hardware input channels. Now I can hover over these and see that bank 0 is my count up, count down, state machine, PRBS generator, and I can select bank 0, press OK. It switches the multiplexer inside the FPGA and defines this bus called count up, so that when I press the run button, I in fact see my counter incrementing as it should. Now, what if I want to look at the individual bits? Just expand the bus. What if I want to look at the down counter? Then I just go up to this little probe icon, and when I press that, I'm able to come back and select bank 1, which in this case is my down counter. And I press OK. Notice it clears out the old data, and now it defines a new bus called count down. And when I press the run button, I can verify that I in fact have a down counter and it's counting down properly. It has selected a state mode, a synchronous capture, to match the state measurement core that I'm using, and it picks the right clocking mode and sets up that input clock so that I can have very reliable capture of the functionality of this FPGA system. With Xilinx FPGAs, it just gets better. If we're doing pin mapping, Now, instead of manually mapping those pins across, I can use automatic pin mapping. The FPGA wiggles each of its output pins, and the logic analyzer scans across its many channels, finding each signal, with the result that I'm able to bring those FPGA pins down onto the proper hardware channels totally automatically. Plus, with Xilinx, you can use a time division multiplexing core and see twice as many signals with the same number of pins. Let's look at the Tektronix solution implemented with the First Silicon Solution FPGA View application. Here we're looking at the interface, and I'm going to select Default System, so we can just start basically from scratch. We need to program the FPGA with our design plus the measurement core so that we can probe these signals we talked about, like the up counter and down counter. I'll need to launch a separate application from Programs. It's called the Altera Quartus 2 Programmer. I'll need to open a third application. It's called the First Silicon Solutions FPGA View for Altera. This is the place where I drag over the FPGA pins and the signals associated with those over to the right hardware channels. And I fill this up, mapping the FPGA output pins over to the hardware channels of the logic analyzer. And now from this interface, this is where I can say, I'd now like to look at this up counter, and I'll click on bank 0. It says switching banks, mapping TLA signals, and mapping operation complete. I'm going to switch back over to the logic analyzer because I'd like to look at this up counter. What I notice is I don't see up counter. I still just have these default signals. I don't have any new bus that's been named as up counter. So I can right click, I can say add waveform, and I'm going to see if I can find my up counter. Looks like it's down here from within this menu. So I'm going to select these. I'm going to press add, and I can see that that has placed them now into the logic analyzer waveform view. So here are our count up signals. I'm going to hit run. Now I'm looking at the up counter. I don't have a very intuitive view here with just ones and zeros. I'd like to group these as a bus. What I'm going to need to do is go back into this setup window in the logic analyzer and create a bus. I'll go ahead and call it up counter, and I'm going to assign to it these bits that are associated with these counter signals. Now if I go back to waveform, I can right click, say add waveform, select up counter, and add it in. I'll drag it down to the bottom. I'm going to expand the time per division, and sure enough, here we see F3, F4, F5, F6. Now I can see that I have a counter that is incrementing properly. Now, what if I want to look at the down counter bus inside this FPGA? I have to go back to my First Silicon Solutions application, select bank 1. If I go back to the waveform view, now I can see count down bits 0 through 7. One thing I'm noticing is that my old signals, my up counter signals, they weren't cleared out. They're still on screen, and yet they've been renamed with new label names. So I'm showing incorrect data here. I see the up counter. If I press run, it should switch the mux inside the FPGA and then capture these down counter signals. And sure enough, I can see C6, C5, C4. It's counting down. But I have another challenge here. The bus I created, called up counter, it's static. It doesn't change or update as I change measurement banks. This is getting a little confusing. The setup is in a default internal timing mode. It's sampling asynchronous to the actual activity from this measurement core. So I have to go in and manually set it up to external synchronous mode to match up with that measurement core. So as we've seen, in comparison to the Tektronix logic analyzer, AgileIns provides an FPGA debug solution that gives you a more reliable view of your signals, a more intuitive view of those signals, and with a process that is much faster. And, unlike Tech, all from a single interface supported by AgileIns technologies. All important things to an FPGA system designer who needs to get their design to market quickly. Thank you.